Hello, builders. We are live and welcome to Building SaaS on AWS. My name is Anthony McClure, and I am a solutions architect with the AWS SaaS Factory and your host for today's show. If you are currently a builder of software as a service solutions, or even just looking to learn how to design, build, deploy, and operate solutions inside of multi tenant environments, then this is the show for you. In every episode, we strive to bring you subject matter experts that can dive deep into the many and varied topics and aspects of building software as a service. And today, of course, is no exception to that. But before we jump into today's content, I would like to first make a big welcome to everybody that is joining us here live today. If you are here live on Twitch with us, please jump into the chat section, say hello to our moderator, Bill Tarr, who is once again there with us, ready to answer and work with you on any questions you might have. And of course, let us know where you're from and what brings you here today. If you do have any questions for our guest or myself as we're going through our content today, go ahead and put those into chat as well. We'll try and bring those up and answer those if we have time. Also, if you're joining us here today and you like this kind of content, you enjoy what AWS is bringing you on our Twitch channel, be sure to hit the follow button. It really helps us out and shows AWS that you like this kind of content. If you're seeing this later on in video on demand, be sure to like and subscribe as well. So without any further ado, let's go ahead and dive into today's topic. Now, in many times in the past, we have talked about reference solutions for building out architecture for SaaS. And we've talked a lot about serverless reference solution. We've talked about our EKS reference solution. But we have a new one that we want to bring to you today. And to help me out with that, I would like to go ahead and bring on our guests for today. As we add them to the show, I would like to say hello to Damika and Kartik, also both solutions architects with the AWS SaaS Factory, but I will let them introduce themselves at this point in time. So who would like to go first?
Damika, you want to start with?
All right, let me
Put
go.
you on the spot
Let me
there.
go,
Damika,
guys.
you're up.
All right, awesome. Thanks for having me, Anthony. Appreciate it. So, hey everybody, my name is Damika Shrianand. I'm a senior partner solution architect here at AWS. Like everyone else who's joining from this side, I'm also part of the SaaS Factory team. Well, SaaS Factory is a dedicated partner program here at AWS that helps with organizations who are building and launching multi-tenant SaaS products on AWS. So in our team, we connect with the AWS customers and partners who are having, SaaS use cases and, transformation projects and help them technically to build the solutions using AWS managed services and also provide the SaaS business support to launch and scale the, SaaS business successfully. So over the last few years, we have done a great investment from our team and inventing on behalf of the SaaS partners and customers in building many reference architectures, new architectural patterns, a lot of prescriptive guidance and repeatable content. So today we're going to dive deeper one of those new reference architectures that we build. Super excited about that, and great to be here, Anthony, and looking forward to the session.
Well, welcome very much, Damika. Kartik, how about you?
Yeah, sure. Thank you for inviting me, Anthony. Hey all, thanks for joining. So I'm Kartik Annamalesamy, and I'm a solutions architect, part of the AWS SaaS Factory team, and I'm based out of India. SaaS Factory has a program in addition to what Damika said. We also extensively work with partners who are specialized in SaaS, and we call them as AWS SaaS Competency Certified Partners, who basically help us to scale out to multiple customers on building SaaS solutions. So happy to be part of the show.
Thank you very much, Kartik, as well. Wonderful to have you both with us. I'm really excited to dive into this topic. So why don't we go ahead and just get right into it? So we're talking about ECS today, right? And for those that aren't familiar with it, Damika, maybe you can just give a brief overview of what ECS is, and then really what I'm most interested in is why is ECS really a good option for even building SaaS?
Yeah, sure. So Amazon ECS is a fully managed container orchestration service that helps for running container workloads more efficiently on the cloud at scale. So the beauty of that is it provides a less complex nature in running containers on the cloud compared to the other, content orchestrators. So, which is one of the biggest reason why we wanted to build a framework that helps our customers and partners to build SaaS on top of this Amazon ECS. The simplicity, less complex nature of the architecture, and also ECS deeply integrates with other AWS services, such as for routing, for observability, for service discovery, and so on. So these are the core building blocks technically when you want to build a SaaS solution in any technologies, any technology stack. So ECS provides very seamless mechanisms integrating with other AWS services, all these features. So that will help our SaaS providers to build SaaS in a more efficient way. So that's a huge plus point for us. For example, when you want to implement the tenant isolation capabilities, handling the noisy neighbors, reducing the blast radius, implementing the, let's say, data isolation mechanism metered in the matrix, and all these kind of core multi-tenant features, ECS supports native support. Because of that, we can also discuss multiple architectural patterns in ECS as well. So in a SaaS solution, typically, you don't have a static one single version of architecture. You most likely your architecture is actually based on your pricing strategy, or billing model, and etc. So based on that, you have different architectural patterns. So
it could be
ECS,
some silo, some pool, some combination of the two. Yeah, there's always that.
Absolutely. So because of this, nature of the ECS that supports the native integration with other AWS services, it provides multiple architectural patterns on building SaaS, which is a great plus point. So I think those are the main core points. If you ask me why ECS when it comes to SaaS.
So maybe the real $1 million question here, right? That our audience may be asking. We have EKS, Elastic Kubernetes Service. We have ECS, Elastic Container Service. Why EKS versus EKS?
Well, I already knew what the question was when you're starting, Anthony. Well, I think the simplicity and the less complex nature of the overall architectural components that ECS introduces is one of the big plus point compared to the other content orchestration.
It's
that also
just simpler, right? If you don't need all of those extra features that EKS brings to the table, ECS may be a good solution for you then.
Absolutely. You don't need all these undifferentiated, lifting and the extensive, components, libraries, integrations, plugins, etc. If you're not using that to implement the multi-tenant nature of your architecture. So ECS removes that part and believes the native integration to the AWS services to provide that, which is a big plus point. And the other reason that goes similar to that would be less complex learning curve for the developers and the architects when they want to kind of adapt to ECS or build SaaS on ECS compared to the other other container orchestrations. And also there's a cost component in here as well, because Amazon ECS customers can create an empty ECS cluster free of charge without paying anything to AWS. So that's a great isolation boundary for a SaaS story. Yeah, you will see down the line that we are talking about different architectural patterns using that just that concept itself. So and this cost efficiency component will become an economy of scale when you have large number of tenants going down the line as well. So those are just few things that I can think about when I compare with the other content orchestrators.
Interesting. So in that case then, and it does sound like ECS is obviously a good choice as far as a compute mechanism for your SaaS solution. There's tons of benefits that come with it, definitely less complexity. You still get all the benefits of being a containerized solution, so that's great. But what about the capabilities specifically of ECS that really help in building SaaS?
Yeah, so that the answer to that really leads into why. So what are the core support that ECS can provide in implementing really the multi-tenant features in a SaaS architecture, right? So if you look at the tenant isolation, we talk about tenant isolation in almost every SaaS architecture that we work with our customers and partners. So In
Bread
ECS,
and
it
butter.
provides
Yeah.
absolutely, and ECS supports a great native feature to implement the compute isolation using VPC security groups, which is a very strong kind of firewall kind of support that provides to us to control the network level traffic that is coming to the tenants boundaries, which is a very powerful feature to implement the tenant isolation at the compute layer. And also, it works very well with IAM roles to support the ECS services that are running in the cluster to implement the data isolation as well. So we're gonna talk about all these down the line, but tenant isolation support is one of the big factor, and the service discovery. ECS itself is having a great nice service discovery feature, but we gradually see that a lot of toolings and support is being provided with service discovery feature of the ECS. Recently, ECS service team have added the new utility called ECS Service Connect into ECS service, which orchestrates the service discovery, working collaboratively with the um, working collaboratively with the ECS itself and also the namespaces that provides the service discovery capability. And also it works really well with the routing components that we are going to use in the SaaS solutions as well. So service discovery is one of the biggest things. And then there are different constructs that you can use in handling the noisy neighbors in a ECS cluster, specifying the compute capacity, service by service, if you want, in the cluster that will have a great control for noisy tenants or busy tenants in your cluster, in your solution. Request routing is always a big topic, and the support that ECS provide is just super simple. Customers can have their ECS cluster fronted by an ALP, and if they have like a few microservices, they can easily go to market to support few tenants. And also ECS supports really good native integrations to scale the routing to support large number of tenants as well. Observability. We can always go with the container insights, but with the service connect coming into the picture, there are more fine-grained observability support with ECS, and also there are many partner solutions are being supported for observability that we can use for multi-tenant environment as well. Last but not least, the additional auto scaling capability that ECS can support, along with AWS Fargate, is a great win especially for highly dynamic SaaS workloads that the customers, SaaS providers are having. They can achieve the operational efficiency using Fargate, where they don't want to control or manage the underlying capacity anymore. But more than that, there will be a cost benefit long term when they have large number of tenants as well. So I would say these are the main plus points and the kind of the primary support that ECS provides for a SaaS provider to build SaaS.
Well, it sounds like a lot of great features, actually, that many that I wasn't even 100% sure of. So that sounds fantastic as far as a platform to build SaaS on top of. So with that being said, then maybe we get Karthik in here. What are some of the main technical considerations then that we have to think about if we're going to go ahead and build SaaS and we're going to use ECS as the the backing service, the backing compute for this? What are some of the main concerns that we run across?
Sure. So I think one of the key things we have to consider is that ECS is more natively coupled with the AWS ecosystem, right? So which would mean that whatever factor we put in as part of the SaaS architecture would need to consider the quota limits and the scales of the dependent AWS services. Right. For example, I've just listed here a table which contains a list of commonly used AWS services along with a typical ECS-based deployment. For example, Amazon VPC, the EC2 underlying cluster, application load balancer, capacity providers, etc. Right. On the right side, I've given the list of basically the limits. Right. In these limits, some are hard and some are soft. So normally when you build a SaaS solution, right, so these limits mostly don't come into picture because they are quite at a very high level. But there are few things. For example, if you take this one, right, the Amazon EC2's network interfaces per instance, right? So this currently largely depends on the instance type, right? And now the SaaS constructs of scaling out to large number of tenants in an AWS account will need large number of ECS tasks running in an ECS cluster, which demands more network interfaces, right? So this is one thing which you have to carefully factor in while building a SaaS on ECS. The other thing I would say is on the application load balancer. Right? So currently ALB is by default the ingress controller for an ECS based deployment, right? And the target groups which the AWS application load balancer supports is currently fixed at 100, and that is hard, right? So target
that
groups
one cannot be extended then, right?
Yeah, it cannot be extended, right? And you would need a separate target group to be created for every microservice deployed in an ECS service. So as you scale to more and more tenants, more and more ECS services getting deployed, which means that you will soon run out of the target groups. So what we have done as part of our recommendation to address these two SaaS constructs is that to start with, for the tenant isolation part, right? So as you scale out to more and more tenants, we have built network level based isolation in ECS across different tenants using security groups. And security groups demands a separate elastic network interface for every task, because basically security groups gets binded itself to the ANIs, right? So given that the EC2 instances support limited ANIs by default, so out of the box, the default setup may not be a viable option for a SaaS-based deployment, because here you are going to deploy more and more tasks as tenants get onboarded. So to address this shortfall, ECS itself provides an option which is called AWS VPC trunking. Right? This is an ECS specific feature which can be enabled at the account level, which will make sure that every supported EC2 instances which you are using as a compute for ECS will be able to have more ENIs. For example, depending on the instance size, let's say for example in M5 large, default it's supposed to ANIs. But when you're enabling an AWS VPC trunking feature at the account level, it supports up to 10 ANIs, which means that it can run 10 tasks. So this is one of the key features which we recommend to be enabled at the account level for any SaaS solution which is getting deployed in ECS-based deployment. The other consideration is on the tenant routing, right? As I said, the more you scale, the more number of target groups you need at the application load balancer, right? It's a target group. Basically, they are the endpoints. You can consider them as the backend endpoints to which the traffic flows. Given the 100 hard limit, there are some architectural level consideration you can take to scale it out. For example, one thing could be that once you reach 100 tenants, you can basically switch to another ALB to cater for the next 100. Right? Again, there are pros and
Create
cons to this
another
approach.
just have a whole separate instance to get another 100 essentially.
Yeah, that's an option, right? The other option which you can also go with is that especially for the premium customers, right? So instead of sharing the application load balancer across multiple tenants, what you can do is that for premium tenants, you can go with the dedicated ALBs, which means, as I shown on the right side, as a product and order microservice. Likewise, a single ALB can support up to 100 microservices deployed for the SaaS application. So as long as your SaaS application is not going to have more than 100 microservices deployed, you can consider this option for premium customers where you have dedicated ALBs routing direct to the respective microservices of the tenant deployment.
Interesting. So obviously there are a few gotchas here, right? As far as using ECS in a SaaS-based environment, but it looks like you've done the heavy lift, right? You've done the research to figure out what those limitations are and how to support them. So that's really important moving forward. Hopefully good information for our audience as well that may be considering using ECS going forward here.
Yeah, that's a simplicity, right? As Damika mentioned, right? Most of the SaaS solution may not need the heavy lifting of other compute options available, right? If your SaaS application is relatively small size, mid-sized, and you're not you're targeting a decent number of tenants, ECS would be a more easy option to go and deploy and launch quickly.
Yeah, that makes a lot of sense. Or especially in those customers maybe that have a fixed number of tenants as well. We find that there are more and more public sector entities, also large enterprises or enterprises that are creating SaaS solutions for their own internal teams or organizations where the number of tenants isn't necessarily growing. It might be a really good solution for those folks as well.
Yep.
Yeah, makes sense. So, all right, great. Let's go ahead then maybe and dive a little bit deeper into some of the technology behind ECS and what these technical architectures look like. So, in that case, Dhamika, what does solving some of these multi-tenant challenges that we've talked about kind of look like inside of ECS?
Yeah, sure. So I think there are two parts here. So we'll first of all go through how ECS can support in resolving core multi-tenant features such as, let's say, tenant isolation, handling noisy neighbors, and extending the routing and things like that. And then we'll talk about how can we build scalable ECS SaaS architectures afterwards. Before getting there, Anthony, I would like to highlight that everything that we discuss today, that has a lot of moving parts. As you mentioned, it came through as a great output of a great amount of R&D as well. So it's very there's a lot of work here. So what we have done is to make the things easier. We have compiled everything together and launch it as a ECS reference architecture on GitHub. So it is public now. We did it like a couple of months ago, I guess, and we continuously adding the features. So this is probably the first time we actually mentioned this at a public setting. So we now have the ECS SaaS reference architecture, which if you share my screen, you will see the kind of the homepage of that. You can also share the link on the chat. I saw Bill has shared already as well. But so this would be the homepage of that. It has all the code and the configuration needed to get this architecture up and running on your AWS account. It has a control plane and separate application plane. It has it comes with the admin console through which we can create new tenants in the solution. Comes with the e-commerce SaaS application, which is a sample application that will be simulated to each and every tenant. And if you look at the SaaS application plane, there are three main architectural patterns we described: pool services, silo services, and silo clusters, which are mapped to different tiers to make it real. It looks like real in actual SaaS application. So when you deploy this solution in your application, you will get this solution. We will have this solution, and then you can log in as an admin and then start creating the different tenants as well. And this is the exact code of the reference architecture I have checked out to my local laptop.
We do have a quick question as well, Dhamika, that came in from the audience. Maybe before we jump into the code, which of course we're all very excited to see. But we got a question here from, it looks like Steve. He's asking, what is a range of a decent number of tenants? That's kind of a broad question.
Maybe I'll take that maybe. Yeah. So I mean, see, in terms of number of tenants that you can host in an AWS account in ECS, it really depends on few factors, I would say, right? For example, the number of microservices which your application is going to have, right? That's one of the key primary drivers which will decide the number of tenants which you can host. Typically, based on some of the POCs which you have done, let's take that you are going to have a SaaS application with 20 microservices or 10 microservices, takes for example, considering all the service limits which we discussed, and also the other limits which may come into part later in terms of soft limits which can be increased. We see somewhere around, I mean, there's no hard and fast number, but just for a discussion, a typical AWS account running a SaaS application on ECS can handle up to 2,000 to 5,000 tenants maybe. Again, the range could be very broad, and it could vary largely depending on the characteristics of your particular SaaS application.
Makes sense. Thanks for answering that. And thank you so much, Steve, for your question. And just as a reminder to the audience, if you do have any questions for our groups here, certainly let us know, right? And we'll try to answer those as soon as we can. So sorry about that, Damika. You were just about to show us some code, but yeah, we definitely want to get those questions.
Certainly a great question. And so what I'm going to showcase over here is actually the code base of the SaaS reference architecture that we have built and launched. So I quickly go through the folder structure just to give a high level perspective. The client folder will have the front end components for the admin UI and the sample SaaS application. And the script folder will have all the shell script that we are using for different utilities in operating the reference architecture. For example, when deploying for the first time, we'll use the install shell script and creating the new tenants, deprovisioning the new tenants, etc., etc. So all the scripts are in here, and the server folder will contain the core microservices, for example, the application folder over here. These are the sample microservices of the e-commerce application that we are using. So you can see the order and the product microservices, for example, and Docker resources and configurations needed to host them in a ECS cluster is here, and also the CloudFormation templates. All the CloudFormation templates to create the new tenants. And the base architecture that we get when we install the solution for the first time, all the CloudFormation will be in this particular folder.
Are we using CDK for that, or what are we using for the backend, or is it just pure CloudFormation?
This is completely a CDK project, so we are fully on the CDK. All the scripts are running on written on the TypeScript on CDK.
Excellent, thank you.
Sure. So having said that, I'll now get back to the question that you asked, Anthony. How do you implement these multi-tenant features using ECS, right? So let's start with the compute isolation. So imagine that you have two tenants, tenant one, tenant two, in a, let's say, cluster, for example, and each tenant will have their own microservices. So if you keep it like this in a single VPC, tenant one resources can easily access tenant two. No one is actually preventing that, right?
Right.
So what do you mean by the tenant isolation in a SaaS solution is that what are the mechanisms that we can use to implement different features, different restrictions, so that tenant one would not access tenant two resources. So there is no cross-tenant access of the resources. How can we do this? So in the ECS, when you're building SaaS on ECS, it provides we take the support of the security groups. It's a VPC construct. Security groups is you can consider that as a virtual firewall that provides you to control the network traffic. So using the security groups, we'll have for example, each tenant will have their own security groups, and then we'll say, hey, block all the traffic so that tenants cannot talk to each other at the network level. So you get the tenant isolation implemented. So that's how it works at high level.
So one thing that I'm noticing here is that if we're comparing ECS to EKS, ECS is using a lot more of the native AWS capabilities and services, right? So, for instance, security groups here for tenant isolation. That's pretty cool.
Absolutely, that's one of the plus one, as I mentioned, when it comes to building SaaS as well, because you don't have to have a lot of libraries and tools and other
things and libraries. Yeah,
exactly. So if I go to the code base to showcase how do you implement these security groups, let me open up this TypeScript, the CloudFormation or CDK script. This ECS-cluster.ts. This particular CDK script will be executed whenever we want to onboard a new tenant, irrespective of which tier they are, right? So imagine now then we are creating the new tenant number 2. So we need to create the order and product microservices and also create the security group as well. So what we need to do first of all is to create the security group, right? So here, what you can see in this code segment is you initialize a EC2 security group in the VPC that you are in, and you allow all the outbound traffic, which means anything that is in the secret group can talk with outside. But by default, all the inbound traffic is blocked at this stage. If you want to enable inbound traffic for each and every port, you have to do it manually, separately. So that is what exactly. So that's what you're going to do in the next slide, next line. So here, what we are doing in this line 88 is that in the security group, you allow the traffic from ALB security group, which is the security group of the application load balancer, and you allow that traffic flowing into the security group, which means that for the tenant number 2, you need to have the traffic coming from LB, which are the traffic actually coming from the tenant 2 users from the outside, right? So that is what you are enabling to coming in. And in the next line, we are enabling the backend microservice port for the internal service communication. For example, if order microservice want to communicate with the product microservice and so on, that port will be used for that. So this way, this particular security group will access only the traffic coming from the ALB, and any other traffic from any other tenants or anywhere will be, rejected. So that way, you implement
those microservices, intercommunication between the microservices, essentially.
Yeah, exactly. So that is how you implement the compute level isolation. We can also talk about how do we support the data level isolation as well. So in this example, there are 2 order microservices in 2 tenants. Each will have their own tenant-wise databases. Idea would be that each order microservice supposed to be connecting to their own order database, and we should prevent things like this where order of tenant 1 will end up talking to any other data source, right? But how can we do this? So when you're using ECS services, we can create IAM policy that specifies the access to the or tenant 1 order DB, and then inject that to the order microservice when it is created as a part of the ECS task role. And so order microservice itself will inherit that IAM policy, which will be used to create the connectivity to the DynamoDB table. So order microservice will only allow to connect to the tenant 1 order DB, not to anywhere else. That way, you kind of preserve the data level isolation as well. So if you are creating the tenant 2, we just need to create a new policy and then inject that to the order microservice. So let's see how it is done at the code level. So I made the same script. So here is where I'm going to actually create the policy document, which specifies what order microservice of tenant 2 can connect to, which is the order 2.
And I see right above that, I can see where you're creating that policy. Yeah, doing some injection.
Yeah, absolutely. So we are creating this policy. Actually, we're taking that policy from a text file. So I should have it somewhere here. So this is the text file example policy. This one that specifies what are the DynamoDB actions that will allow someone who's having this policy on which resource, right? So this table ARN will be actually replaced by the actual table ARN after the table is created at the CloudFormation level. And so the policy will be then injected to the microservice.
So it acts as a template, basically, then, for that.
That's correct. So when you have that policy document, you simply go ahead and create IAM role out of that, and you call it as a task role, and you can add any other managed policies into the same task role as well. And then the important thing here is that you include that task role as a part of the task definition of the order microservice. And that task definition will be a part of the service properties, which will be used to create the ECS service. So working backwards, when you want to create the ECS service, you need the service properties. Service properties will have a task definition, and in the task definition, you can specify the task role that has the policy specifying which database or data stores that this microservice can connect to. So the microservice will take that, inherit that policy, and to create the connectivity to the data store, which will ensure the data isolation as well.
Yeah, and the great part of that is we're using all AWS constructs here that we're all familiar with building with all the different services that we have access to, and using those AWS constructs to ensure that it's impossible in this case for tenant 1 to access tenant 2's data. Very good.
Yeah, certainly. And this is for the handling the silo databases. When you want to handle with the, for example, shared databases, there could be scenario one database is shared across multiple tenants. You use the same pattern to kind of inject the, IAM policies if you want, and then, implement role-based access control or attribute-based access control in that case as well. And we actually have those kind of databases in reference architecture, and we have used the same IAM dynamic policy-based IAM fine-grained access control to handle the shared databases in the ECS SaaS architecture. All right, so just a couple of things I want to cover real quick is, one is about the noisy neighbors. As I mentioned earlier, you can specify in the task definition, you can specify the memory and the CPU limits like this, so that the services that have been created out of this the task definition will have those memory and the CPU limits. So when those tenants are getting noisy or busy, you have some control in terms of the infrastructure consumption at the compute layer. Additionally, we can always go with external mechanisms like API throttling implementation for handling the noisy neighbors, which also we already have it in the ECS SaaS reference architecture. And the other important thing is, like Karthik mentioned a couple of strategies about extending or scaling the routing perspective, but we also build our own routing mechanism to support the SaaS routing. For example, like as Karthik mentioned, right? So if you have 5 microservices in one tenant, ALB needs 5 target groups, right? You run out the target groups very, very, very easily because it's only 100 available.
Right.
So how can we support in scaling this is, we actually use a different, like the new routing component inside the ECS cluster, while we handed off to do the tenant-wise routing to the ALB, which means that now our ALB will do the routing looking at the tenant ID only, and then it will figure out the tenant ID. All the traffic will be sent to another routing component, and we have implemented the routing component using Nginx. But this time, not as the ingress controller, but as a reverse proxy. So if we go to the application, and then you will see that there is a reverse proxy folder here, in which you can find the Nginx config. So this Nginx config, as I mentioned, we are using as a reverse proxy, which means that it represents the ECS services in the cluster in terms of APIs, and then map the APIs using a proxy pass. So this is the API definition for the order microservice, and then it maintains a proxy pass that refers to the actual order microservice or order service inside the ECS cluster, and this proxy pass is actually being handled by the ECS Service Connect. So ECS Service Connect basically take the request coming from the ALB and work with the Nginx reverse proxy to identify where which service that we need to pass to, and then do the routing within the cluster itself. So it's a very seamless mechanism and scalable as well, because now we don't need as many as target groups to route the request to the microservices, because ALB will do the routing by the tenant ID, and the Nginx will do the routing
like
to
all
the
internally within the cluster. Yeah,
that's correct.
So in that case, then we really only need one target group per tenant in this case, or something close to that.
That's right, because you just need ALB just need the reference to hand off all the traffic, which is the Nginx, And then from there onward, Nginx will take care of. So for that communication from ALB to Nginx, there's only one target groups required. That's all.
Awesome. Great. For those of you that may be joining us late, didn't start with us, and why didn't you get here a little earlier next time? You are watching Building SaaS on AWS, where I'm joined today by Karthik and Damika of the AWS SaaS Factory team, and we are talking about the new ECS reference solution that they have been working on, and it's out and available to the public today. So, anything further that you want to point out there, Damika, or maybe we can move on to some architectural patterns next?
Let's move on to the architecture patterns. I have a few more things, but I think given the time, let's move on to the architecture patterns now.
Sure, sounds good.
Yep.
All right. So yeah, Karthik, you want to talk a little bit about the architectural patterns of SaaS here, or multi-tenant constructs?
Sure. Let's start with the conceptual view of the stack, which we recommended in the reference solution, right? So our reference solution has a sample UI, both on the admin console and the SaaS application. And when it comes to the SaaS control plane, we have built it based on AWS SaaS Builder Toolkit, right? SaaS Builder Toolkit, as people will know, it's more of a framework with some set of reusable components built with best practices on building SaaS from AWS. And our reference solution is leveraging SaaS Builder Toolkit to build the control plane and all the other common constructs which are required in a SaaS solution. So we have the control plane on the left from SaaS Builder Toolkit. And then we have the plumbing pipeline, right? So you need to have your application plane where you're going to host your application on ECS, the SaaS application, and also the interface between the control plane and the application plane. And how SaaS Builder Toolkits handles is via events. So we have an Amazon Event Bridge provision, which kind of standardizes the interaction between the application plane and the control plane. Then as part of our ECS SaaS reference solutions, we have recommended 3 tiers, right? So different tiers have different capabilities in terms of deployment. So starting with the basic tier, it's a completely pooled deployment model where you're going to have common ECS services getting deployed per microservice in the SaaS application, shared across multiple tenants. So this model doesn't support network level isolation out of the box. So it's mostly at the data level where we implement isolation leveraging the IAM policies. The next we have the advanced tier. This is more of a version where we do support network level isolation at the compute level using security groups, where we have security groups wrapping the respective ECS services of the particular tenant. So the traffic cannot cross the boundary. And we also have a third tier, which is a premium tier. The only difference in terms of the deployment between the advanced tier and the premium tier is that premium tier is deployed using a dedicated ECS cluster, right? There'll always be
So they have their own resources. Yeah,
they have their own resources. The EC2, underlying EC2 is not shared. So maybe there will always be some set of customers who will demand this scenario, and this would be ideal for them. So now with that context set, let's quickly look into the details of how the architecture is in the respective tiers. So starting with the basic, as I said, we have common microservices being deployed across all tenant, product, and order microservices. And to have the service-to-service communication, we are leveraging ECS Service Connect. So ECS Service Connect is again an out-of-the-box feature from ECS, which enables service discovery and observability within the ECS cluster. And ECS Service Connect depends on some of the AWS services, especially the cloud map, which you need to map it to enable the service discovery within the cluster. Mm-hmm. So now with that infrastructure setup, how does the traffic flows? So starting with the left, so we have the traffic coming in from the internet into the VPC. The ALB receives it. And within the ALB, we have dedicated target groups, which are pointing to the respective microservices.
Routing per tenant.
Yeah, it's basically routing. It's a common deployment. So it's like for every microservice you're going to have for a particular tenant, it's going to be having a separate route. Right. So given that this is a shared deployment, you can support up to 100 microservices in this deployment based model, because ALB obviously has a target limit of 100. If you're going to have a SaaS application which is deployed in a completely pooled deployment model with more than 100 microservices, then you may need to consider a parallel ALB, right? Which in most cases would be an edge case scenario.
Mhm.
So moving on to the advanced tier, right? So this is where we have the respective tenants isolated by security groups. As you can see here, we have security groups covering the respective tenants deployment. So we have 2 deployments of our service and 2 deployment of product service corresponding to every tenant. And like with the basic tier, we also have the ECS service connect deployed separately for the respective tenants. So as Damika mentioned, in the case of routing for this deployment model, what we have used as part of the architecture is that we discussed parallel ALBs, but there's another option which we have explored as part of this architecture, which is leveraging a reverse proxy solution. Right. So what happens is that when the traffic flows into the ALB, there will be one target group dedicated for every tenant, which will route all the traffic to the particular tenant for all the microservices to a common reverse proxy solution. So we have leveraged Nginx in the reference architecture. So this Nginx component is going to receive the traffic for that particular tenant and then route it to the respective microservices. So again, it's a scale mechanism where you can basically support up to 100 tenants in a single ALB in this approach.
Okay.
So moving on to the next deployment model, as I said, the premium tier. The architecturally, the components between the advanced tier and the premium tier remains the same. The only difference being that it's completely deployed in a separate cluster, which means that the underlying EC2 resources are also not shared. So basically, these are the 3 reference solutions in term based on the tiers which we are recommending as part of the AWS SaaS ECS reference architecture.
Oh, that's really fascinating. I love how this comes together using so many great AWS services. And then, although we are having one extra here in Nginx, we're just using it again as that reverse proxy lookup to get us to the microservices. Very interesting layout here. Thank you for that, Karthik. So we are, of course, time flies so fast as we are running through our show here today. But it's great content. I know, Domika, you maybe had some things that you wanted to show us here as well.
Yeah, real quick. So this is what you see. This is the admin SaaS admin panel. What you get when you deploy the CSRS reference architecture in your AWS account, right? So it has only one link to get you to the list of the tenants. So here I have actually preloaded the solution with few tenants. Some are from the basic tier and then one in the advanced of the premium tenant. So it's pretty easy to kind of create a new tenants. You go here and give let's say tenant name and email,
Like
and
the
then
admin.
select
Yeah, right.
whatever the tier that you want to be, and you just submit it. So then it will be taken care by the um, the code build projects that we have set up internally, which I can also showcase. So this is my AWS console related to the SaaS kind of the deployment of the ECS SaaS that I have the version. So you will see that there is a the code build project has started here, and that code build that code build will take the one of the shell script, which is provision tenant shell script to deploy the tenants. And it will look at the tier ID, which is now in the basic tier. Based on the tier, it will call the relevant data, the CDK scripts, and then get the solution, get the tenant up and running. So in the basic tier, it's nothing much to do because there's no infrastructure to create, just the
Right.
onboarding of new tenant and configuration to set. So that the routing will be set. So the new tenants will be driving into the shared cluster. But if I select a advanced tier tenant or a premium tenant, this shell script will connect with the right CDK projects and build a CDK stack, start a CDK stack to create the new infrastructure required before the tenant is onboarded as well. So that's the tenant onboarding happens in the ECS SaaS reference architecture. So I want to quickly go through that part.
Yeah, no, that looks that's fantastic. So that of course takes us through the onboarding of the customer, right, and getting them up and running, or excuse me, the tenant in this case. And like you said, these different tiers that we're talking about here as well. These are examples, right? So in your particular organization, you may have different tiering structure. You may even label them differently, but it's really to show the different levels or styles of architecture that we can apply here from a SaaS perspective, and it's implemented very well in the solution. So in this, kind of tier-based, deployment model, Damika, how was, I think you explained it a little bit how it's working in the background, but especially I think if it's a premium tier is probably the most interesting one. So maybe what does that one look like?
Yeah, so the premium tier basically to take the CloudFormation template to create the new new cluster. That CloudFormation template will basically create a cluster, new cluster, and deploy the microservices separately. Create a new security group, configure that, and add all the microservices there, and configure the routing to the ALB. So that whole thing will be conducted as a part of the tenant onboarding process, because premium tier customers will have a dedicated ECS cluster. Yeah, I think, Karthik, if you can maybe go through like one, like a workflow of the routing. If you
Sure.
choose the premium tier customers, that will bring like a good idea about how the flow happens at the AWS component levels.
Sure. Yep, I can. So to simply put, right, to simplify things, right, when it is going to be a basic tier deployment model, it's just going to be adding the tenant identifier into some set of tables. No infrastructure is deployed. But when it comes to a premium tier or even an advanced tier, in our case, there is some level of infrastructure plus configuration that needs to happen. Right? So let me quickly go through some of the key components which gets created as part of the tenant onboarding process. I'll focus on the ECS cluster because that's where the area of focus is now for today. So as you could see in my console, so we have 3 clusters created, right? So we have the basic cluster, the advanced cluster, and there's a dedicated cluster, which is basically for a particular
that would
tenant.
be per tenant, right? Yeah, because those
this
premiums would be per tenant.
This is the premium tenant. Yeah. And let's dig into that, right? So if you can go into the premium tiers cluster.
It wants to load today.
Yeah.
Is that a demo effect?
Yeah, it's always right.
It's a feature.
It's a feature. Okay. Yeah. Can say like that. Yep.
Yeah. So
there we go.
As you could see here, right? So if you can focus on the services, right? So that we have order service, product service, and user service, which are the application services, and then we have the reverse proxy, which is also running as a service within the same cluster, which takes care of the tenant routing.
Right. And that's where the ALB connects to first, or the ALB connects.
Yes. Yes, it does. Right. So getting into one service, for example, order, right? So if you can check inside that. Yeah.
Fun with console.
I think I've opened. Yeah, I've just opened it. Let me check another area.
No, that's fine.
Yeah, it's fine.
We're
Yeah.
good.
So we have the set of tasks which are running for the respective order service. And if you can just scroll down and check here, you see the containers, right? So this is where the Service Connect comes into picture, right? So as Damika mentioned, we have used Service Connect as a discovery tool. Service Connect gets itself deployed as a sidecar within the particular ECS service. So any traffic which is coming into the order container will have to come through the Service Connect. So that's how.
But that is an AWS managed component, right?
Yes, exactly. That's the most important thing. We are not managed.
Right.
That's right. Yeah.
It's a fully AWS managed component. Right? So now in terms of this is the setup, right? Be it a basic tier or advanced tier or the premium tier, This is how a typical task deployment will look like inside your ACS cluster. So now getting into the routing aspect of things, as you could see, the routing for the advanced tier and the premium tier happens to the reverse proxy, right? So if you can check the reverse proxies target group, I've opened a sample target group here, right? So this is a target group where the reverse proxy is configured to, and it is pointing to a load balancer, right? And from the load balancer, if we can view, for example, let me start with the basic TS routing rule, right? So I'll just filter for basic here. Yep. So we have 3 routes. As you could see, every route corresponds to a specific microservice. Right? It is not actually targeting to any reverse proxy here. That's how a basic tier is configured within the ECS reference solution. But if you check the other tiers, advanced tiers and the premium tiers, for example, I'll take the first one, right, where this is for a particular tenant, it is actually forwarding it to one target group, and that target group would be mapped to the reverse proxy.
Got it.
And the
That
reverse
makes sense.
proxy takes care of the routing from there on.
Wow. Well, that's
right. So
yeah. This is so fascinating. Dominic, did you have a quick final note here?
No,
Or something
no.
to
I
add?
think
Or just saying this?
that's
Yeah.
the answer for you on
this
your
is
question, and then this is how the flow happens actually. Yeah.
this is a
Yeah. No.
core flow.
Yeah, no, it makes perfect sense, and it's very elegant, right? I think that's one of the things that I really like about the ECS solution versus EKS. And look, I'm a Kubernetes fan too. So, but in reality, for doing these kinds of traditional web apps, but deployed in a as a SaaS sort of solution, ECS is a really compelling option here, and I think it's definitely something folks should take a look at when you're trying to decide, what kind of compute platform, especially if you're already into or working with containers. But folks, we're actually just running really short on time today. Karthik and Damika, thank you both so much for being here and presenting the new solution that you've been working on. Everybody in chat, please, take a look at the code, deploy it, see how it functions. If you have any feature requests or comments or concerns related to it, let us know back at the SaaS Factory. We really want that feedback. And in any case, as we let you go here today, remember that we do have another show coming up in a couple of weeks, and Karthik is going to be back with us on that show as well. So we'll see Karthik joined by a partner of ours, and how we've kind of implemented SPT in a different way with those guys as well. So Karthik, Damika, thank you both for being here today. Everybody out in our audience, thank you for joining us here today. Be sure to jump back in with us next time, and we'll see you on the next episode of Building SaaS on AWS. Thanks, folks.